This video is sponsored by Omron Industrial Automation. In this video, we're going to talk about how machine automation controllers, or PLCs, are using cloud computing as part of the IIoT in the new industrial revolution, also referred to as Industry 4.0. We'll look at how two industry-leading Omron controllers interact with the cloud and store and use data on SQL databases in machine processes. First of all, you might ask, what is a machine automation controller? A machine automation controller combines the traditional PLC electrical circuit logic functions with high-speed motion controller functions required for extremely precise and lightning-fast position, velocity, and torque control. This new evolution of PLCs that we've referred to as machine automation controllers has evolved even further into a device that easily fits in with other devices of the IIoT. Okay, well, you might ask, what exactly is the IIoT? First of all, IIoT is short for Industrial Internet of Things. Before we move ahead, let's quickly clarify the difference between the IIoT and IoT. Whether we know it or not, most of us are already taking advantage of the IoT. We've got domestic smart devices like video doorbells, thermostats, and alarm systems that all connect with us through the internet. As the name suggests, the IIoT is part of the IoT, but concentrates on the connection of machines and devices in industry. So back to our question, what is the IIoT? You can find a never-ending list of articles and descriptions through internet searches. But let's try this explanation. Consumers that are part of a digitally transformed business enterprise have access to any and all data when wanted. Okay, that's a mouthful. Let's break that down a little. A consumer can be a human or a device. A business enterprise can be many things, including a factory or several factories. Digitally transformed means that consumer devices like instruments, sensors, and other devices are networked together and communicating with computer-driven industrial applications for various functions and control. Human consumers need ready access to data for business management. For all of this digital transformation, there needs to be considerable computing horsepower to transform, manipulate, store, and handle all of the data. Some or all of this computing horsepower may be owned by the business enterprise itself, or it might be on the cloud. So, what are the cloud and cloud computing? In a nutshell, cloud computing is the use of internet-based IT services for data storage and computing power as opposed to using local extranet-connected servers. The ever-growing list of cloud computing providers includes Amazon Web Services or AWS, Microsoft Azure, Google Cloud, and many more. Industry-leading PLC manufacturer Omron has developed a series of IIoT-ready machine automation controllers. The Omron NX102 and NX701 PLCs can communicate to the cloud via OPC UA, or Open Platform Communications Unified Architecture, which is an open industrial protocol. Omron's PLCs have embedded OPC UA servers, allowing connection to a variety of platforms such as Windows, Linux, or Android. These two Omron PLCs also have an SQL client built into the CPU, which can talk directly to an SQL database. This essentially eliminates middleware, as the PLC can connect to an SQL database wherever it is. SQL, or Structured Query Language, is the ANSI standard language for relational database management systems. The Omron Sysmac platform shares data from Omron controllers using three methods: Embedded SQL Client, OPC UA Server, and MQTT function blocks. Later, we'll talk more about MQTT. We keep talking about data. There's lots of data that can be captured from the factory floor that could be invaluable for business matters, such as quality control, raw material supply, the manufacturing process itself, and many others. Here's an example. A company makes widgets. A machine vision system is capturing, storing, and timestamping images of the widgets in production. If there is a recall, The images can be used to track down and isolate the small number of defective widgets, thus preventing a recall of perhaps thousands of widgets. Okay, so where does the cloud enter into the picture? Here's another example. Two manufacturers are working together to fabricate a piston for a large automotive company. These manufacturers are in different cities. They are IIoT interconnected through OPC UA to the cloud. The first manufacturer takes raw material and shapes it into a piston, then stamps a barcode on it. The barcode provides details on the work done on it. The piston is shipped to the second manufacturer that does further machining and drills the holes. The final remaining machining details reside in a database and are read by the second manufacturer. After reading the barcode provided by the first manufacturer, the second manufacturer proceeds with machining the piston. Let's finish this discussion with MQTT. MQTT, or Message Queuing Telemetry Transport, is a very popular publish-subscribe messaging communication protocol for IoT devices, allowing the exchange of data via cloud services. It is an open and standard protocol that requires a broker. A broker such as HiveMQ is a commercially available intermediary entity that enables MQTT clients to communicate. A broker receives messages published by clients, performs message sorting by topic, and then distributes them to subscribers. The Omron machine automation controllers can accomplish MQTT via Sysmax Studio communication function blocks, as it is not built into the PLC. For example, the function block MQTT client controls the connection with the MQTT server. This means that you don't need to write any program for your PLC to communicate with an MQTT server. All you need to do is to add this function block in your logic and assign the right parameters to it.